All right, guys, welcome to ITS 350. Please make sure that your names are clear on the Zoom participants list so I can make sure that everyone is in the class. So please change that if, all right, or identify yourself, I guess. Otherwise, I'm going to have to remove you from the class. So today, as you know, it's a short week. That it's Thanksgiving break, right? Starting tomorrow. So the plan for today, it's just a short lecture. As you know, I'm not doing any more labs at this point. I just want you guys to work on your term project. So really at this point, all you have left is your term project and your final written exam. And that should be pretty much the semester. If you had any homework assignments, I don't remember, just make sure you submit them. But I believe everyone has submitted everything. So hopefully during this break, I'll have an opportunity to finish up all the grading. So I'm hoping really to be done with everything grading wise by this week. So today, just a short, very simple lecture. As you know, we really just have this lecture left and the lecture on Tuesday, a week from today. The Thursday of next week is just going to be an open lab. So, just basically if you have questions about anything, the project, etc., remember that maybe I should go to the calendar, I guess. All right, so let's look at the calendar just to go over. And today at the end of class, I don't anticipate that the lecture will take the whole class. So I will stay over for a few minutes. So please, if I have thousands of emails of students submitting homework that they should submit via Brightspace, through email, and a lot of emails. So if you can help me out by just asking the questions directly at the end of class today, please just ask your question. We can go into a break room if you'd like, but I would appreciate it if you just ask the questions directly there. So I'll make a little bit of time, as I said, for any questions that you might have. So let's go to the calendar just really quickly. So as you know, we are at the very end of the semester. Yeah, you can just ask questions. You can email, but if if you can just ask the question directly, just do that, please. Today, as I said, is the 24th of November. So today, actually, I'm going to do this topic, intrusion detection systems. Is one of the odd things that we have in the class that is a little bit outside of the scope of everything else, but I'll cover that today. And then after that, I just have a few miscellaneous topics, wrap up, risk and control matrices, risk assessment, and then a few things like denial of service, which has to do with availability. If you remember, that's one of the principles. We haven't really talked about availability, so I'll talk about this, do a lecture on it. But as you can see, basically, we just have today and it's December 1st, 4 lectures. December 3rd, work on project. Presentations will be on December 8th, okay? So you need to do your presentations. That means you'll do a PowerPoint and a demo in your groups. And then for those groups that for some reason have technical problems or anything like that, you can still present on December the 10th. Obviously, that day is the last day of class. So I'll just do a course wrap up, any questions you might have for the final exam. And then the final exam will be during finals week. I haven't checked yet when the exam is. I believe it's probably on a Tuesday. You can always just Google this. If you go to Google and you just type PNW final exam schedule, find the fall 2020, obviously, and then you'll find the appropriate date. All right, I have updated the calendar at this point with all the videos that we've done and everything. And as I said, today we're just going to do IDS. which is one topic in the syllabus. It relates to network security, and we have a course on network security, actually. So I'm not entirely sure why we still have that there, but you know, I'll cover it a little bit today, just to make sure everything is covered of all the topics. So let me download the slides. Right, so as I just said, right, I just described this literally. So we will be, I have 2 lectures, right? 2 lectures left today and December 1st. However, they're not going to take all the time, so I'm going to leave enough time, 20 to 30 minutes today and on December 1st. Plus, you'll have December 3rd, the whole day, to ask any questions that you might have, okay? So just, stay. Please don't just leave at the end of class. Stay over. You can go in a breakout room or anything like that. And we can just, ask any questions that you want, right? So as I said, we're done with the semester. Pretty much everything that's left is just miscellaneous little topics here and there. And I'm just covering all my, I'm just dotting all my I's and crossing all the T's in the syllabus, right? Making sure I cover everything. So I usually have these 2 topics left, or these 2 days, just a miscellaneous. But really the bulk of the class, which was the principles in cryptography, has already been covered, right? So you guys already did your practical. You saw that was pretty easy. And I saw some of the results. They look pretty good. So that's great. That was good. I hope you liked it. I wish I could have made it a little bit tougher. I just didn't really have that much time. I wanted to make a more challenging exam, but I thought that one was at least a little bit fun. All right, so let's go ahead then. Yeah, so what was I doing? I was downloading the slides for intrusion detection. I don't know if I clicked on this, I'll click it. So open. All right, so now I probably need to switch to this. Okay. I believe you guys should now be seeing the slides. All right, so intrusion detection. So as it turns out, the security classes that you guys take here are kind of divided into like cryptography. I mean, there's a lot of them, right? So there's like crypto, which is this one. There's software assurance, right? There's forensics, a whole bunch of others, and there's network security. And then, obviously you guys take a lot of networking courses. So I'm just talking about one in particular, network security. So usually we like to have a lot of the courses, grouped like this. Now this topic IDS, which I'm going to cover here, it's actually also covered really well in network security. This is your ITS 454 course, so you're probably not there yet. You still need to take a lot of networking classes, I'm sure, before you get to 454. So that, probably in a year or 2, it's usually actually like one of your final classes when you're a senior. But anyway, this topic, I just want you to know that really this topic, if anything, is just an introduction. So anything that has to do with firewalls and intrusion detection systems is really network security, and those are topics that are very well covered, in depth in 454. Here today, I'm just going to do a quick, as I said, lecture on both of those topics, intrusion detection and firewalls, just to kind of introduce the topic. I'm sure you've also looked at it in your other networking courses. All right, so basically we're going to make it, this does not really involve cryptography. I mean, it's not a topic of cryptography, really. Right, so it's not really a topic of cryptography. but it's really, is more of a topic of network security. Okay, and so we will cover it. I believe, I guess it has to do with if you think of access control as a principle of information assurance. So if you think of, we've talked about integrity, confidentiality, availability, authentication, right? And if you think about authentication, usually authentication is tied to a user, right? Some kind of identity that non-repudiation. So then access control kind of comes in there because it does the same, right? It grants access to things or not. And that's where intrusion detection, and in particular in firewalls, which are access control, they could be viewed, I guess, as a principle. So in any case, whether it's justified to be in here or not, we'll cover it a little bit. All right, so intrusion detection, okay? And I should say, and firewalls, because I want to stress the difference between these two. They are actually a little bit different and a little bit the same. So first of all, we have to define what is an attack, right? An attack, and we've talked about this as we were talking about the risk assessment, the threats, associated with assets. So basically, we're talking about attacks such as people getting your information for, password, right? And that affects authentication, social engineering, again, authentication, launching an exploit, which could affect confidentiality of information that is stolen, or availability, right? A system gets taken down. Code injection, so that has to do with exploits, right? Attackers trying to inject code and affecting the integrity of your code, basically, because they're changing it, for instance. Port scanning, again, getting information. Denial of service attack, which we will cover a little bit as it relates to availability. So there's a lot of attacks out there, and I'm sure you've covered many of those in 250, which is basically your attacks, exploits course. Remember, these courses, like 350 is a defense course, not an offense course. So anyway, so these are some of the attacks out there that can happen, right? And the security goals that can be affected are, as you know, availability, integrity, confidentiality, authentication, accountability, right? And we've already defined all of these, so no need to define them again. You guys have been doing this all semester. Just I remind you, don't forget what these things are, because the final exam will be comprehensive, so you could expect questions related to these again. All right, so as you have an attack, then, usually you're gonna try to categorize them, create a taxonomy of them. What type, are they active? Are they passive? Are they attacking a host computer? Are they attacking network devices? Are they attacking an individual application? So a lot of this, as you have all these attacks, obviously all semester we've been looking at a defense mechanism, which was basically cryptography. But here we're going to look at a little bit of something called access control, which is basically to try to, if there's some kind of an attack going on, can we possibly stop it? Either stop it or at least detect it, right? So that that's usually the difference between firewalls and intrusion detection systems, right? That one is basically there to stop something, whereas an intrusion detection system may only be able to detect it. And that's one of the differences, although there are more. So we've talked about a lot of the countermeasures that are in place, right? Encryption obviously has taken a lot of attention this semester, but there are access control is now one, and in particular, like firewalls, intrusion detection systems, etc. Right? So we have all these defenses, and there's many. For this semester, really encryption, and today we're going to talk a little bit about these two topics, and really as they relate to access controls. Okay. But this again goes back to the idea of your risk assessment. So now that you've identified some of the threats, these are some of the controls that you can have in place there as well. And then I'm not going to talk about these individual attacks. I mean, you've covered these in 250 already, so it's something that I'm going to skip. But I will mention some of them. So scanning tools are important, right? And here you can see, you know, for malware, obviously we all know about antivirus, and we know about firewalls, right? Which are devices, network devices, that they basically analyze packets and basically say if a packet, based on the fields that it contains, it contains, you're going to say if a packet is allowed to get through the network or not. Okay. Another tool is, you know, this is an intrusion detection system. It's one of the classic ones out there. Snort, it's called, and it's basically a system that is an intrusion detection system. Again, today, as I said, I'll be talking a little bit about these two. Okay. So an IDS, IDSs can be categorized in various ways, right? They can be categorized based on the location, that is to say, where you place the IDS. So if it's located somewhere in the network, right, in the actual, between the switches, the routers, or if it's placed like in the operating system itself on the OS, right? So your Windows machine at home, for instance. All right, and then also intrusion detection systems can be categorized into at least 3 types, which are called signature-based, anomaly-based, and behavioral-based, all right? And I would argue then that an intrusion detection system that is rules-based is really a firewall. You know, you could argue that, right? So because a firewall, at the end of the day, you have a network, right? And then the network, you guys have studied in your classes, all your networking classes, that you have a packet, and a packet is divided into individual headers, right? So you know that a packet is actually made up of headers. What are the headers in a packet, for instance? On a TCP packet, let's say, what are the headers?
They tell the packet where it's going.
Right, the headers tell it, but what are the headers in a packet? What are some of like, for instance, there's the Ethernet header, right? And that just in the OSI model, that allows it to deal with the electrical things, let's say, right? But what other headers do you have?
Isn't the MAC address or somewhere?
The MAC address, okay, sure, but that's a value, right? That's a value, let's say, in the Ethernet header, right? The MAC address. The next one is the IP header, for instance. SYNAC is not a header. SYNAC is a flag in a header. So again, you guys are telling me flags or variables in headers. Source and destination. This is almost funny now. So source and destination is also fields in headers. So here, so what I'm saying is, in electric, you know, when you set up a packet application, sure, okay, that would be in the OSI model. But as we speak about a packet itself, right? It's really, you know what a packet is, right? It's a little bit of information that is sent through, you know, from A to B, right? You have your network cable, let's say, and you're sending bits of data. They have ways of knowing when it starts, when it ends. And the data is grouped into little encapsulations that make up an entire packet. So if this is an entire packet, inside each packet is made up of individual headers. So this is the Ethernet header, this is the IP header, this would be, let's say, the TCP header, and then this is the payload. And you know, we can probably make that one a little bit bigger, and that's the payload. And they have defined sizes, right? 10 bytes, 20 bytes, etc. So in essence, whenever you're talking about networking, just like if you're a marine biologist, what do you talk about? You talk about fish, and you talk about mammals in the water, and you talk about water, right? Ocean, vegetation, things like that. That's the medium that you explore when you're a marine biologist, right? So if you were a networking scientist or a networking engineer, networking specialist, whatever, the medium that you study is, right, the cables there, the network itself, the connections, and then the packets that run through it, right? The packets that run through it. And in this case, the packets, as I said, for an Ethernet packet are the Ethernet IP TCP payload. So what you guys, a lot of you mentioned about the MAC address, the SYN and ACK flags, I think somebody said source and destination port, or I think they said source and destination IP numbers. All of those are fields, right? So all of source and destination, port, source and destination, MAC, and so on, right? So all of those are fields, including the payload, which has a lot of data. They're all fields in the packet. All right, and so why is this important? This is important because when you have a firewall or you have an intrusion detection system, those systems have basically imagine that they have like a pipeline. They have at the kernel, if let's say we're talking about the Linux operating system, so we're talking about the kernel of Linux. Linux will have a certain pipe, and it's got some port numbers and some listening hooks, so that the data comes into the device and it goes into this pipe. So every packet now in the operating system, let's imagine your operating system is just some box, but it's got a pipe, right? It's got a pipe, and this is network 1, this is network 2. Any packet that goes in here and out here, first it'll go through a series of modules in the operating system that can take every single packet that goes through it, dissects it into pieces, and then it's going to analyze it against its rules. Okay, it's going to analyze it against a set of rules. And so that's where the firewall and the intrusion detection systems come in, because what they will do is you usually end up using a library in C++ called the libpcap library. And that library allows you to grab that data as a buffer, and basically you split it into all the headers by creating all the structures that that you need. And then what you guys said, for each one of those, you check the fields, right? These fields that you were talking about. And it becomes a whole bunch of if statements that will decide, if the packet goes through or not. Okay, so that's really the idea. In both systems, the firewall and the IDS need to have this mechanism. Okay, so there's going to be some code here, and the code written in C++, and that code's job is really just to be a scanning tool, a scanning tool. All right, which is what's stated there. So they will dissect the packet, break it up into parts, look at all these fields that you guys correctly mentioned, right? And then make decisions based on that. And usually the decision, for instance, for a firewall is, okay, do I drop it or do I let it stay, right? So when you guys take 454, we will go over a lot of types of firewalls. We will do some firewalls that are, how to write the firewall in C++. We're also going to look at the IP tables firewall, which is the built-in Linux firewall, which is really powerful. And then we will, if we have access to the lab the pandemic is over, right, we will have our Cisco equipment that we have over there, which is basically the same thing. It just uses, type Cisco type commands. All right, so that's basically the idea. but at the end of the day, it's all the same principle. You know, same idea. You have a box like this one, and then packets go through it. So basically, one key thing that, you know, that's different between a firewall and a regular computer is that your regular computer usually just has one network card, right? ETH0, something like that. But a firewall or an IDS usually has two network cards. So there's going to be, because it's connected to two networks. So the data comes in through here, it goes through some code over here, and then it comes out on the other end. So there's that idea of two network cards and all of that, making it basically a router, and then after it becomes a router, making it a packet sniffer. Okay, and so basically what I was talking about with the headers, you can see this with the OSI model, right? You can see how it relates to that. So you can see here, you have your upper layers, and then they become encapsulated with TCP or UDP as they start going down in the OSI model. Then you add the IP header, and then you add layer 2 Ethernet headers, and so on, until you have your information that you can send across the network, right? So that's the general idea. So the thing that we want to understand is that for a firewall or an IDS to work, we have to be able to have a packet scanner, all right? A packet scanner, and that's usually done with, either libraries like Wireshark, TCP dump directly on the computer, but also you can write code like C++, which can use built-in libraries like libpcap. So keep in mind that Wireshark and all those programs were actually written with the libpcap library. Okay, so that, that's pretty much the basic idea. All right, and so once we understand that, then we need to understand that there's differences between firewalls and intrusion detection systems, okay? So let me actually, before I get into all of this about IDS systems, I'm gonna add a slide here. Oops, sorry. So let me add a slide or two. Okay, and I need to share this somehow.
What I do?
I need to share this, guys. Hold on. All right, so you should now be seeing a blue slide. All right, so what I was saying is, so once you have, in the operating system, right? So think about it, a router, a switch, a firewall, an IDS, all of those are just Linux. Okay, so first of all, they're firmware, but they're still operating systems, and they can basically be Linux. So again, the main idea is you have, first of all, an OS, let's say, or firmware Linux, and then you have two network cards, right, connected to two networks, and then in here you have the code. Okay, you have the code, let's say TCP dump, Wireshark, or just regular CC++ code. As you know, what's going in here is packets, network packets. So a network packet, I already showed you back here, they can be broken up into these headers, right, according to the OSI model. And so now the key thing is, as we take a big picture of the code, the packet comes in, we know it's a packet, a TCP packet or whatever, we break it up into the different headers. So Ethernet header, IP header, TCP, oops, that's not what I wanted to do. TCP headers, and what's the other one? Payload, right? Payload. And this is just for TCP. There could be UDP, ICMP, all kinds of things. So once I have this, you know, I'm really going to have either a firewall or an IDS. And this is really what I want you to understand out of all of this in your exam. When I ask you, I want you to understand these differences, okay? So both of them will take the packets as they are here. So both of them will take them, okay? Both of them will take them, right? And you know, you could actually have a firewall and an IDS system. But here's where you have to sort of try to understand the differences, a little bit of the differences. So the firewall, and remember, these firewalls can be on your Windows machine, so they can be host firewalls, or they can be network firewalls, where you actually have them deployed in the network. Usually when they're in your host machine, they only have one network card. When they are in the network itself, obviously because they're between two networks, they will need to have two network cards. So once you go through the firewall, what's going to happen is the firewall will match these packets to a series of what are called chains, okay, a series of chains. And we'll see that in a lot more detail, as I said, when you take 454, the network security class. But for now, I'm just, I guess, giving you a little bit of an introduction. And so the packets will need to go through these chains, and in these chains you specify rules. So that's all that you have in a firewall. All right, so a firewall will be, so someone has said, you know, destination port, right? So destination port number. All right, so let's say that, you know, what's one common destination port number? Who can tell me? What's a common destination port? Anyone? So a common destination port would be port 22, right? Let's say that you have a server. You have a server over here. What's port 22?
Is that SSH?
SSH, right? SSH, exactly. SSH, so you're trying to make a communication via SSH. So you have the packet, so it's an encrypted actually, right? The payload is encrypted. So the code will then, you know, the firewall is as simple as if, you know, destination port in that header equals 22, right? Then you might say that you don't want to allow any packets going to 22 to reach the objective. So then what do? Let's say packet dot drop. You see that? And that's basically how a firewall works. You just drop the packet. Or you say packet dot allow if, you know, depending on the rules that you're inserting. But at the end of the day, a firewall is basically these rules, you know, sort of if statements, heuristic rules that you define as a series of chains. Now, there's a lot more to it depending on what, you know, when we look at IP tables in 454 and we look at Cisco type of firewalls, you know, with the new firewall systems, ASAs, etc., the more modern ones, you're going to basically be doing the same thing. Really what happens there is you spend some time learning about the commands and everything, but at the end of the day, the idea is this, right? And that's why eventually you will do a lab where you will code this, you know, so we'll have to learn how to break through code through the libpcab library. We're going to have to learn how to break up the packets into the pieces, and then basically just write these if statements, okay? Which with Linux, we have the IP tables library, which will make it a lot easier for us. All right. I believe a lot of you are taking 372 next semester, so if you aren't in that class, make sure you take it because you know, you need to become, you know, really good at Linux, and that class is a Linux course. All right, so now that I've talked about firewalls, then you might ask yourself, okay, I understand everything about firewalls, but what is the difference between firewalls and intrusion detection systems? Well, let's first, before we think about the differences, let's think about the similarities. All right, so an intrusion detection system, again, needs to have some kind of a scanning tool, right? It needs to have some kind of a scanning tool, just like the firewall. So basically, it'll take the packet, it breaks it up into pieces. Now, the difference with an intrusion detection system is now there are several differences. Number one is an intrusion, whereas a firewall either drops or allows packets, sometimes it logs them, but usually it's about dropping or allowing them. Here, an IDS has a slightly different purpose. And it might be just to find attacks. You know, so for instance, if somebody is trying to reach port 22, that's not necessarily an attack, right? That's just somebody needs to access port 22 on another machine, but you've restricted it, right? You've restricted it because whatever your policy says about that. You're a school, you know, believe it or not, here at the university, for instance, you know, the IT department does not really like people SSHing into computers, right? So that's only reserved for administrators. So usually that's not an attack, but it's just not something that they want to see happen. And so usually that is blocked, okay? And they, you know, they'll have multiple ways of doing that. But that's not an attack. An IDS is focused differently. An IDS is a little bit like an antivirus scanner, like, you know, Semantic or any of those that you probably have on your computers, the built-in Windows one. It's basically, how does the, who can tell me, how does the antivirus scanner on your machines work? How does it work exactly? Who can tell me?
Usually works based off of either whitelists or blacklists of certain files, or it could even compare, say, hashes of known viruses or whatnot, and look at that and immediately cancel.
Why
Lock
hashes?
them out.
Why hashes?
Well, unless the actual executable file of the virus changes, it's going to have the same hash no matter which machine it gets put on. So if it sees one that matches that the hash of a known virus, then it has to be that. So it kills it.
Exactly, right? That's one of the concepts you learn in the cryptography class this semester, right? We learned that we can use hash functions to create unique identifiers, which were of fixed length, right? Remember, they were just a fixed length, and the input could be variable length. But as long as that file doesn't change, the next time we compute the hash, we still get the same hash, right?
Right.
And that's what you just said, and exactly. And so then, therefore, the malware then has a list of these hashes, and then now whenever we scan the operating system, we look at all the files, calculate their hashes, see if they match these blacklist or whitelists, and there you have it. That's a virus scanner, right? That's what you said?
I mean, yeah, that's one way it could be implemented. I'm sure there's a lot of different implementations that
Yeah.
antivirus
And
software
that's called
uses, but
static filtering. There's also dynamic. We might talk a little bit about that next week. But yeah, very good answer. So now that we thought about it, so what's the key thing with malware? Malware analysis. The key thing is that, so as far as the list, what do we have in that list exactly? So what is that list made of?
could be hash values
Of what?
of known viruses.
Very good. That's what I was looking, that's the answer I was looking for. Known viruses. All right, so those are known files that are executable and can cause, you know, an attack, you know, something, some action, right? Well, that's known viruses, very good. So here, with as it relates to IDS, that's why I said IDS is similar to antivirus in the sense that they both, you know, both firewall and IDS will break up a packet into parts. But like I said, a firewall can just block SSH, and that's not a known attack, right? See, the only difference here now is that instead of saying known viruses, as you said, right, we're going to now say known network attacks. Do you see that? And so an intrusion detection is, whereas a firewall is just, you know, writing rules about any things that could not, that are not attacks, an IDS is usually defined as a system that scans packets and compares the information it's getting from the packets to a list of known attacks. These are going to be a different kind of attack. They're not necessarily malware anymore. They are just a more general classification of network attacks. Does that make sense, guys?
Yeah.
Yeah. So now the key question is, how is this list comprised? So you said very well that the list of malware was made up of hashes of files, and that's, you know, very good. That's what you're searching for. And an intrusion detection system, remember that the medium you're analyzing now is packets, right? Packets. And so what happens now is that what you have here, the list of things that you're going to scan against is going to be called the list of signatures, right? And these signatures are basically, you know, important characteristics about a specific attack. All right, so there might be characteristics of a specific attack. So let's say, for instance, that there's an attack, right? There's an attack. You know, it's a SQL injection attack, right? SQL injection. So SQL injection attack is an attack on a database, right? So that means it's going to have, if you've taken your SQL courses already, at least one of them, you remember, right? What, you know, SQL is what? You have like select, all, ... right? So it's going to have, first of all, the packet has that. And then it also has as a destination port, maybe it's a specific port that it always attacks, 5,000. And by the way, it seems to come from a specific source, right? And so you have yet another parameter here, and so on. So what happens is that research, you know, cyber security engineers will look at that attack. Let's say that the attack happened, they attacked, you know, Bank of America, they hired a team, they investigated the attack, and they determined, yeah, it was a SQL injection attack. The packets that did that attack had this information, and that information. And so, oops, sorry. And so the engineers then conclude that any packet that has those three pieces of information or more constitutes the signature of that type of attack. Let's say the network SQL attack, you know, something, making it up. But that defines the signature, and so now they have this information. So now with this information, they create a signature on the IDS system, right? And now you have, you know, let's say signature 1, signature 2, 3, ... You have all of these signatures as a database in your environment, right? So you have all these signatures as a database in your environment. So now when you have a new packet that comes in, it's only going to break up the headers of the packet and compare it to all the known signatures. If they receive a packet, oops, that meets these three conditions, it's going to trigger an alert, what is called an alert, because they've detected the characteristics of a known attack. Does this make sense, guys?
Yeah.
And that's it. That's the difference. So if I asked you on the exam, what's the difference between a firewall and an intrusion detection system? What would you guys say?
Well, a firewall just prevents certain packets or whatnot, just blanket in terms of all packets to stop them from accessing specific ports or doing specific tasks, versus an IDS actually reads those packets and compares them to a list of signatures of known attacks to decide whether or not they're allowed to go through or not.
Perfect. Very good answer. Excellent. All right, that's it. That's actually that's what I want you to understand. Okay, that one of the key things that I want you to understand, I guess, in this lecture, is the difference between firewalls and IDS. Okay, as I said, these are topics that we'll cover with labs and everything. Several labs when you take your network security class. But it requires a lot of IP tables and a lot of knowledge of a lot of things. All right, so now going back here, then you can see that we've talked about firewalls and how they work, right? And you have a sense of that. And we've talked about IDS, intrusion detection systems, which is in the description of the course. So you understand first of all the difference. Then the other thing is, intrusion detection systems can be on the network, as I said, or on your host machine. So you can, for instance, you could install Snort on your machine and it would be a host IDS. But you could also set up Snort you just take a Linux machine with 2 network cards, right? And as I said, this is something else that we have in the lab. We have these Raspberry Pis, which have 2 network interfaces. So we were able to actually build whatever we want on the Raspberries, any kind of system. So hopefully, when you take 454, because you're not taking it next semester, we'll be back in the lab. So we'll be able to build from those Raspberries actually routers, and because they have 2 network interfaces, and then on them we can build our own firewalls, our own intrusion detection systems, and then of course that will give you a lot of intuition into just building your own things. And then of course we can use the Cisco equipment. So that's really the idea with these. Okay, so it's actually good that we're not covering it this semester. So we'll be back in the lab, I'm sure. So that's the location. And then after that, the classification of intrusion detection systems is that we have what we just described, right? So there's actually 3 types, at least, of intrusion detection systems. And so far, we've defined the signature-based, right? The signature-based, and hopefully that makes sense. But there's actually a few other potential ideas. This one, if you've ever heard of something called machine learning, I don't know how many of you have heard of that, of artificial intelligence, right? There are nowadays intrusion detection systems based on that, okay? Based on that. So I want to take this opportunity to tell you that Professor Tae-Hoon Kim is offering 265 next semester, ITS 265, which is called Introduction to AI. It should be it's the first time it's being offered. It should be a very interesting class. I believe it's going to become a required course of the plan of study. So maybe talk to your advisors or Professor Jang if you have any interest in Professor Kim's course. That's Tae-Hoon Kim, Dr. Kim. So just you have I'm sure he can explain to you how to do machine learning AI for an intrusion detection system. All right. So the one that I'm going to talk about today is the other one I'll talk about today is something called the anomaly detection IDS. So anomaly-based, I guess. Anomaly-based IDS. We'll talk about that a little bit. But I've talked about the signatures already. I think it's pretty straightforward. Just a whole bunch of rules and heuristics. So I think, Dakota's definition was very good. So I believe that pretty much summarizes it really well. All right, so now if we continue, and please stop me at any time if you have any questions or any doubts about anything, please. Okay. So now, network IDS, as I've talked about it from the location point of view, it just means that, you have, your switch over here, right? And then over here you have a node, and that node in the network is your intrusion detection system, okay? So this will have advantages and disadvantages. It's easy to deploy, has a wide coverage, early detection because it potentially detects things before they get to your machines. but it can have high false alarm rate because it's capturing all traffic, right? All traffic in the network is going through that. So obviously that means a lot of alarms. And IDS systems actually have problems with that. And obviously you need a high performance device because think about it, you know, the code that's running in your IDS, it's slowing down your network. Instead of just taking the packet and forwarding it to the next step, the IDS could be inspecting it, looking at it before it releases it, especially if it's what is called an intrusion prevention system. And so that, you know, can slow down the network. And we've talked about performance, you know, a lot already. We've talked about performance a lot already and how important it is. So going back to this idea, what if, so I have a question for you guys. What if you know this signature, you know that signature, right? You know that packet, but the packet as it's going through the network, currently it's encrypted and it will not become unencrypted and delivered to this until it reaches the host. So what do you think happens in that situation? Let's say that, you know, this select statement is actually encrypted, which, as you know, what does that mean? It means that it would be a whole bunch of gibberish, right? So what do you think will happen to the intrusion detection system if this is gibberish? And, you know, that is to say, if it's encrypted as it goes through the network device. What happens to that signature? What do you think?
Would it let it through since the
It lets
signature
it
would
through, right?
match?
Exactly, because the intrusion detection, it's not a magical tool for breaking encryptions, right? It doesn't know how to break the encryption. The encryption is between, let's say, this point and that point. And so, you know, if it's between these 2 points, they exchange the keys securely. So the same things apply. As it goes through the IDS, you know, that will not be able to catch the encrypted message. So think about this, right? If this is going to be encrypted, it will not be able to interpret it. Do you see that, guys?
Yeah.
That's where, sorry, go ahead.
Oh, I was just saying, yeah, I see what you're going with.
So that's where a host IDS might actually be better because of the encryption. When the packet gets here, it'll be decrypted probably before it's injected into like the OS for wherever its destination is. So at that point, the host IDS could be able to scan it, right? So that's why that brings up the important point that, you know, actually having a network IDS and a host IDS are good, right? So you can see that the blue circle here just indicates that the host IDS is located on the device, okay? Has more accuracy because it's usually now the IDS is focused on only things that it cares about, could be more precise, you know, encrypted things, right? It'll be able to look at them. Obviously, it might be a little bit harder to deploy because it's extra load on your host machine, late detection because it's, you know, the attack made it to the machine, but it might be detected before it's allowed to the final destination. So that kind of gives you an idea of the differences between network IDS and host IDS. Okay. Any questions about that?
I don't think so.
All right. Good. Signature based, we already talked about it. I think that makes sense. And you can just see here, I just took an example from Snort over there. And as you can see, Snort has its own specific language that says trigger an alert if I get a TCP packet that meets, I have 2 variables, external and home, and that's probably like ranges of IP addresses, right? And then it says for any port to, let's say, that port, where the content, and you can see here, contains this, these are hexadecimal, this is a call to the shell, right? So the people that developed some signature, you know, figured out whenever you see this payload and that information there, that is the IMAP exploit. And that's a well-known network attack. And therefore, they will basically trigger the alert, right? So that's what That's the language of Snort, and a lot of intrusion detection systems do that. So an intrusion detection system is the mechanism that takes the packets, breaks them up into parts, and scans them, and then comparing it to a list of rules. So really, you might say that the money is in the whoever holds the best list of rules, right? They're the ones that are going to make the most money. And it's a business, right? So you know that from McAfee, right? That McAfee is at a point where it's almost a virus, right? It's always there. So, but it's a business, you know, they try to sell, and you know, it's got important value, of course. Now, anomaly-based, the last one that I'm going to cover. So what do you guys think anomaly-based would be? Who could give me, you have a kind of an intuition of what the signature-based is. So what do you think anomaly-based would be?
I would assume that it establishes some kind of baseline of normal traffic that that comes through it, and then if it notices something that is outside of that baseline, it would go after it.
Exactly. Perfect. Very good. That's exactly what it is, right? You know, an anomaly based is exactly that. You establish statistical models of normality, and then anything outside of that. So you guys have taken your statistics courses, right? And you know that, you know, there's a normal distribution, right, with a mean and a standard deviation, and how many, you know, things like that, right? So things that are closest to the mean are more normal. Things that get outside of it are less normal, right? And so that's really the idea. The idea is that you're trying to find things that are outside normality. You could also think of it as, you know, like that, right? This being the mean, the center, right? And then, you know, this kind of follows, you know, a distribution like that. So anything that starts to get outside of it is an anomaly. Why do you think we need these? Why not just use the signatures? What would be the purpose of the anomaly? We have the signatures, right? Can't we just have all the signatures in the world?
No, because new stuff is being done
Stuff,
every day.
exactly. There's attacks that are called the zero-day attacks, right? Zero-day attacks, and that's an actual term, and it just means attacks that are very new. Remember when I said the signature takes, you know, they'll spend 6 months researching it until they make their conclusions. But initially, though, the researchers will, you know, they won't have mechanisms for zero-day attacks. So they want to have something. I mean, it's better than having nothing, right? And so what they do is they develop these models. So it's detection of attacks by measuring deviation from statistical models of normality. They can look at things like traffic characteristics, protocol compliance, content, call sequences, etc. So advantages: detection of unknown attacks, right? Disadvantages: also a high false alarm rate, you know, because an anomaly is not necessarily an attack, right? You know, an anomaly can just be that, you know, it's end of the year, everyone's working really hard, and you know, they stayed late, and boom, the network thinks that people are stealing information because there's so much network activity at, you know, late at night. So that's really the idea with anomaly-based systems. Okay, so anomaly-based detection, sample network activity to compare to traffic that is known to be normal. When measured activity is outside baseline parameters, the system will trigger an alert. Anomaly-based detection can detect new types of attacks in theory. It requires much more overhead and processing capacity than signature-based, but it may generate many false positives. So it, you know, thinks that it thinks are bad but aren't actually. Okay, but it, you know, as I said, it's something to have in place. So you can see that here with an example. You know, CPU process size, right? So or activity, you know, how many processes you have active, and then usually you have this, and then one day you have a spike like that, right? So that, you know, definitely, maybe not probably an intrusion, but probably at least an anomaly, right? It's certainly something that might require a little further studying, basically. So that's really the idea. Okay. All right, and then here's an example. You can read through that. Now, what follows here is an actual algorithm of how to implement an anomaly. You can see that. I'm not going to go into this, but I left it in here. You know, I teach this in another class, you know, grad level class. But here, you know, just take a look at it. I mean, if you have an interest in it, certainly you might find it fun, but you know what's important here, you can see is you have a, you know, data, a representation of your data, and then you have, you know, if something falls within this, that's okay, but if it's at a certain distance, right, you know, it becomes kind of an anomaly, and so basically you might want to take some action there. All right, so you can take a look at the algorithm, as I said, if you'd like. I'm not going to go over it at all. All right. And that's basically it. I mean, everything else that follows here is just a summarization of the pipeline, how you take the packets, really. You can take them from logs or from the network, and, you know, the whole process. So that's the pipeline there. It's pretty much everything I've said, just summarized into slides. Okay. And then a little bit about the libpcap file. As I said, we'll cover a little bit of more, a lot of that, I should say, in the network security course, including snort and everything. All right, so that's pretty much the slides for today. As I said, I don't have, you know, today is just kind of miscellaneous. I wanted to make sure I got this topic covered. So now, as I said, I'm going to pause the video at this time. This concludes the intrusion detection systems lecture. So let me go into